curve and an axis. Before we do that, we need to understand the meaning of the word bounded. Right, so what does area bounded means? Just to give an example, if you're inside the house, right, if you're inside the house, you're bounded by the ceiling, the walls, and then the floor, and you're inside there. Right, so the word, another meaning for the word bounded, it's to be enclosed. Right, so if you're in an enclosed area, like this example that I gave you, you're inside the house, you're bounded by the ceiling, the walls, and the floor, then you're being enclosed, so you're being bounded. Therefore, if you want to find an area that is bounded by the curve, right, the area has to be underneath the curve, bounded by either the vertical lines, the horizontal lines, or any lines, and also the axis. So another example that you can use is that you can imagine that you're underneath the umbrella, and to avoid getting wet, where do you need to hide? You have to hide underneath the umbrella, right? Yeah, so there are two examples that we have on the screen. One is bounded by the x-axis, and one is bounded by the y-axis. So if you look at the x-axis, if you have a curve, let's say it goes this way, and if you name this curve as y equals to f of x, right, so you imagine that the curve is actually the umbrella you're holding, and then in order not to get wet, right, you want to be hiding underneath the umbrella. So that is the region, that the area of the region, the shaded region, is that you're interested to find, and this region has to be bounded, right? So it's bounded by the curve, this one, by the two vertical lines, right? We can let this point here, the vertical lines, we can let the equation be x equals to a. So the x coordinates on the x-axis will be a. Let's say this vertical line, it's x equals to b, the equations, and this point here will be this x coordinate on the x-axis, let it be b. Right, so to find this area, then let's check if it's bounded. So we have the curve, the two vertical lines, and of course bounded by the x-axis, very important, this is the x-axis. All right, so to find the area, we will have to integrate from a to b, right, f of x dx. Okay, this is what it means. Right, so if it's bounded by the y-axis, then you imagine that the wind is so strong, and then tends to be flown off, and then trying so hard to catch the umbrella, and then you're flying horizontally, right? But you're still underneath the umbrella. So let's say the curve goes this way, right? And we want to find the shaded region. So in this case here, we're talking about the y-axis. So it's bounded by the two horizontal lines. Let's say y equals to b, y equals to a. So the y coordinates here will be b, the y coordinates here will be a, and let's let the equations of this curve be x equals g of y. All right, so area of this shaded region will be, you will have to integrate from a to b, g of y dy. Okay, it's dy because you're actually getting the limits from the y-axis. So how is it bounded? Let's check now. So it's bounded by the curve and the y-axis. Let's do one example. Let's examine this curve. Right, so this curve has a function that's given by y equals to x bracket 3 minus x. Right, let's check if this curve is bounded. Yes, it's bounded by, that means the region that we are finding is underneath the curve, and it's also bounded by the x-axis, right? And the limits given to you are from the x-axis, right? So to find area of this curve, area of the shaded regions, okay, so we will integrate from 0 to 3 x bracket 3 minus x dx. Alright, we will have to expand this before we can apply the integration rules. Okay, so to integrate 3x, right, power 1 plus 1 gives you 2, then divide by the new power. Then for x squared, it will be x to the power of 3, because 2 plus 1 gives you 3, divide by 3. And we put in the limits. Okay, let's try to simplify it first before we do the substitution. Right, we substitute x equals to 3 first. So that will be 3 over 2 bracket 3 squared minus 1/3 bracket 3 cubed. Close it. Minus, now we substitute x to be 0, and you will get 0, right? Because 3 times 0 over 2 is 0, minus 1/3 times 0 give you 0. So basically you just minus away the 0. Alright, you can use the calculator to work this out, and that gives you 9 over 2, which is 4.5 square. Right, relatively easy. Another example, right, in part 1 you're supposed to find the area of the region A. So let's check how is it being bounded, right? So it's bounded by the curve, by the two vertical lines, and by the x-axis. Okay, so if it's bounded by the x-axis, then the limits that we'll be taking will be from the x-axis. Right, so for part 1, area of region A will be equals to, we're going to take the limits from 2 to 3, because the area is bounded by the vertical lines x equals to 2 and x equals to 3, right? And then integrate 5 over x to the power of 2, then dx, right? So can you see that now? See, the limits are taken from the x-axis. You're integrating something with the x respect to dx. So everything is like x there, you know. Right, so how do we integrate this? Before we apply the integration rule, we will have to convert 5 over x squared into the negative index. So that will give us 5, then times x to the power of negative 2. Alright, 5 is a constant. You can just extract it out from the integral. And then negative 2 plus 1 will give you negative 1 divided by negative 1. Then we put in the limits. Simplify it before you actually put in the limits. It's easier. So 5 divided by negative 1 is negative 5. X to the power negative 1, you can write it back as positive index with 1 over x. right? So that will gives you 1 over 3 minus, make sure you bracket the second term because there's a negative sign here. So minus 5, then the square bracket 1 over 2. Right, and this, just be very, very careful. You can just use a calculator to help you get the answer. Just make sure you punch it into the calculator carefully. So that will be negative 5 times fraction 1 over 3 minus bracket negative 5 again times fraction 1 over 2, close the bracket, and you get 5 over 6 units square. Right, so that is part 1. Okay, so how about part 2? Right, so part 2, we are asked to find the values of k such that the area of region B is equal to the area of region A. Okay, so both these two regions have the same area. So let's check part B, how is it bounded? So it's bounded by the curve. It's bounded by the vertical line x equals to 3, the vertical line x equals to k, and the x-axis. So for part 2, area of region B will be equals, you have to integrate from 3 to k. The same curve, we're talking about the same curve. So we've already done all the groundworks at part 1, right? So all we need to do is just to take, the one that I put the 2 asterisk there. So that will give us negative 5, 1 over x, and we sub in the limit k and 3. So that is negative 5, 1 over k, minus bracket negative 5, 1 over 3. Okay, let's try to simplify it first. Right, negative 5 is negative 5 over 1, so you multiply numerator, that gives you negative 5. Multiply denominator, 1 times k will be k. Minus times minus give you a positive. That gives me 5 over 3. Alright, so this area, this guy, is equal to the area of the region A, which found early on to be 5 over 6. So we can bring a positive 5 over 3 to, that means you take away 5 over 3 on both sides. So it becomes 5 over 6 minus 5 over 3 on the right hand side. And if you use the calculator to just help you work it out. Negative 5 over 6. So negative 5 over k is equal to negative 5 over 6. So k will be negative 5 over 6 divided by, sorry, wrong. Here we can do a cross multiply easier. But we can multiply both sides by negative first, negative 1. So you will get 5 over k equals to 5 over 6. Do a cross multiply, 5k equals to 30. K will be 30 divided by 5, give you 6. Even if you need to find the area of the region that is below the x-axis, alright, if you look at this shaded region, is bounded by the x-axis, bounded by the 2 vertical lines and also the curve, but it's below the x-axis. Then can we still apply the same rule? Right, so to answer the questions, let's have a simple example. Right, let's say I want to find the area of this shaded region, which is a triangle, and let's say this, the equations of this straight line, it's y equals to 2x minus 5. All right, it's at a positive gradient, and here it's the y-intercept is negative 5. The x-intercept is, you let y equals to 0. X will be 2.5. So here the x coordinate is 2.5. So how do you find area of this triangle? So area of this triangle will be half times the length here, which is 2.5, times the vertical height was -5. So you will get -6.25. But we all know that if you need to find area, it's actually a positive it's a positive quantity, right? Area cannot be negative. So how do you actually change it to a positive value? You just have to negate it, means you just have to multiply with a -1, and then you end up to get a positive value for the area. So we can use the same reasoning. So for this example here on the left, right, the area of the shaded region, if it's underneath the x-axis, then it will be negative. Whatever rules still apply, it's just you need to put a negative in front of it. Let's say this curve is given to be y equals to f of x. So it will be just dx. Alright, we'll do one example at the next slide. Let's look at this example. Right, so if I want to find this area, look at the small little area that I need to find, which is bounded by the x-axis, the curve. Alright, the vertical lines are x equals to 0 and also x equals to half. This is x equals to half. Because you're given the x coordinates of point Q, it's half. Also bounded by x equals to 0, which is this line here. Okay, right, so basically it's a bounded region, just that it's below the x-axis. Right, so if it's below the x-axis, what do we do? Area of the red shaded region, because there are two shaded region there, we're finding area of the red one. Let me write it properly. Right, so we will have to okay, wait. So remember, we need to put the negative sign in front of our the formula. So we integrate from 0 to half, and then our curve, which is 2x cubed plus 4x squared minus 3x dx. Alright, so let's integrate it. Right, integrate 2x cubed, you will get x to the power of 4 over 4. Integrate x squared, you get x3 over 3. Integrate x to get x squared over 2. Let's put in the limits. Alright, simplify it before you actually submit the limits will be easier. So that will give us half x to the power of 4 plus 4 over 3 x to the power of 3 minus 3 over 2 x squared, and then limits. Don't forget the negative, the negative must be there. So we're going to put a huge curly bracket there. Right, so now we can submit the limits. Half bracket, half to the power of 4 plus 4 third bracket, half to the power of 3. Right, and then minus away. Okay, if you substitute x to all your x to the power of 4, x to the power of 3, x to the power of 3, you get 0. So basically just minus 0. And this you can just easily use a calculator to help you work it out. Just make sure that you punch in carefully and correctly into the calculator. Right, and you will get a negative 17 over 96. Right, so this negative and negative become positive. So you will end up getting a positive answer for the area of the region that shaded red. Other different questions. Why is it different? Because if you to look at the diagram carefully, the area that we are asked to find, this shaded region, is actually above the curve. It's not bounded by the curve. It's actually bounded by the line y equals to 20. Let's say if it's y is equals to 20, let's sub x to be 2 to make sure. And x is 2. Right, use your calculator, work this out. Yes, it's 20, correct. Right, so it's bounded by this horizontal line y equals to 20. This line is y equals to 20. All right, bounded by the vertical line x equals to 4, and it's above the curve. It's not bounded by the curve, it's above the curve. All right. So in this case here, we need to employ a different concept. So what are the concepts that we have to use here? Right, the concepts we have to use here is, first of all, we have to find the area of the rectangle. Right, which is the one that are highlighted in blue for you. Right, and then 2, we have to find area bounded by the curve. And the x-axis, and the two vertical line, x equals to 2 and x equals to 4. So this area that we're talking about is the area bounded by the curve, right, which is the red, maroon region. Okay, then finally, to find the required area of the required region, okay, you find it by taking area of the rectangle minus away area bounded by the curve and the x-axis. All right, so these are the concepts involved. So let's do the first part first, the easy part, area of rectangle, right, which is just basically length times breadth. So the length will be just 4 minus 2 units. That gives you 2. Then the vertical height will be 20 units because it's bounded by the by the horizontal line y equals to 20. So 2 times 20, and that gives you 40. So we're going to keep that because we need that later on. Right, so the next step is to find area bounded by the curve. And we integrate from 2 to 4. The equations of the curve, which is x cubed minus 9x squared plus 24x dx. Alright, so that's integrated. Put x to the power of 3 over 3. Sorry, you get x to the power of 4 over 4 minus 9 over 1, x to the power of 3 over 3 plus 24 over 1, x squared over 2. Then you put in the limits for 2. Right, so I would advise you to simplify the expression first before you do the substitution. So the chances of you making mistake will be reduced, right? And please have patience, okay? Be patient or have patience. Be patient when you do this kind of substitution. Sometimes you just want to quickly get the answer, but if you're not careful, right, you will make a mistake, and it's not worth making this kind of mistake knowing that you know how to do just careless mistake. The next step is just use a calculator to punch in the values into the calculator, not punch the calculator, sorry. 64 minus 64 minus 28, that gives you 36. Alright, so therefore I'm going to write it here. So therefore area of the required region will be area of the rectangle, which is 40, minus the weight area under the curve, which is 36, and the area of the shaded region will be 4 units square. Area of the required shaded region.